Okay, you should have a quiz for me, so you can turn that in, please. Thank you. Okay. Thank you. Thank you. Okay. I don't know. It was just handed to me by your neighbor.
Yeah.
Thank you. Last call.
Okay. There you go.
Thank you. All right, anybody else? Okay. Well, do you have the other part? Let me see the other part that you're copying.
Sorry.
Let me just see what you have.
Copying this, and then this is the solution.
Okay, that's fine.
How's the quiz for today?
That's the quiz for today. Yes. Okay, some other business to attend to. So I posted in Canvas a file that has directions on how to solve systems of equations using your calculator if you're using a Texas Instrument calculator. So I have this as a handout also. We may use this here in a minute. See if I have enough there. I think we'll have plenty. Should be enough there, just in case. Yeah, if there's extra, just leave them on the desk. Anybody just coming in, please turn your quiz in right away if you have it. Make sure y'all turn that in right away if you have it. All right. Here you are, James. Make sure you turn in your quizzes. Those of y'all coming in late, let's get the quizzes, please. Y'all are holding up class. All right.
No, I got mine. It's just I didn't want to get my.
Thank you. Anybody else? Thank you. Is that it? Is that everybody? Okay. So, I thought maybe we would go back to this textbook and pick one more problem out of here, and then I made up a problem before class, and I don't know, it's a monster. So I thought maybe we might mess with it. But here we go. So again, I haven't looked at these, but Scott, I'll let you.
Okay.
Just anything from in here would be fine. Did you have a good weekend? Yeah. If you had a good weekend, you're not working hard enough.
I'm not even aware they have weekend tomorrow.
Did you find something?
So number 52
Let me see it.
is x squared plus 3x.
Oh, let me get this in here. Hold on. So we're trying to do integral x squared
Plus 3x plus 2
over,
over x, and then open parentheses, x squared plus 2x plus 2.
all right. Looks good. Thank you.
Yep.
All right, so, of course, we make sure there's not something simple for us to do. I don't really see anything too simple. No? So, what do y'all think? Partial fractions?
Probably factor the bottom.
Well, if we have to check, so if we're going to do partial fractions, we first want to make sure that the degree of the numerator is smaller than the degree of the denominator, right? So what is the degree of the denominator? It's x cubed because that x has not been distributed through. So we do not need a long division step, right? So the next step would be to try and factor the denominator. Now it's already factored in terms of an x has been factored out. We just need to see, can we factor that trinomial right there? And it does not factor, right? So we're kind of there now. We're at the point where we have to come up with how can we rewrite this. So we're stopping the integral for now. We're going to try and do our partial fraction decomposition. Is there a way that we can rewrite this so that it's like something over something, something over something added together? So we look at our denominator and we look at the factors and we try and identify what type of factors we have. So x by itself is what type of factor? It's a linear factor. And for every linear factor, we should put a constant over the linear factor, right? Now, it's not repeated because it's not squared or cubed or anything like that. If it were, then we would have to add another, like b over x squared, c over x cubed, something like that. But we don't need to. And then we have a quadratic factor, right, that's irreducible. And what if it did factor? Like, what if this did factor?
You have two unique.
Yeah, then we would have this linear factor, and we would have two distinct or unique linear factors. So we would just wind up having like a over something, b over something, c over something. Does that make sense? But because it doesn't factor, we have to put the quadratic on the bottom, and then what on top? Bx plus c. Must be a linear expression. All right? And then we go and play our game. So we multiply both sides by the LCD. It should clear out the left side. And on the right side, let's see, what do we have right here when we multiply by basically by this? The x cancels, right?
Yes, sir.
And then we're left with the a next to the quadratic, right? And then over here, you have to be a little careful here. The quadratic will factor, or will cancel. We'll still have bx plus c, but times what? X. Okay, so that's where we are. I'm not showing that step, right? Is that okay? Sure? Okay. So now, shortcut, short method, long method. Well, in this case, you'll never kill this off. Okay? You'll never kill it off because it doesn't factor. So let's just do the long method. So we'll just distribute everything out or expand out the right-hand side. So I'm just distribute my a through ax squared plus 2ax plus 2a. Then over here plus bx squared plus cx. Now we match our coefficients, right? We combine like terms, I should say, and then we'll match the coefficients. So I think I'll do that on just move this back up here. All right, so I'm going to write the left-hand side down again, x squared plus 3x plus 2 equals, and let's see, my x squareds, here are my x squared terms, here and here. So I'm going to put those together, and I'm going to factor the x squared out, right?
Yes, sir.
And I factor that x squared out the back side instead of out the front side. So I'm going to have a plus b, and then x squared. That takes care of those, right? And now I'll get my x terms together, which I have this one and this one, right? Those are my two x terms. So I'll put those together and factor out the x out the backside. So I'll have plus 2a plus c times x, right? That's this. And then we have by itself just 2a. And that makes sure I've got everything there. Yeah, everything's taken care of. Now's the matching of the coefficients. So I'm going to go ahead and look at the coefficient in front of x squared over here, which is 1. And I need that to match up with the coefficient on x squared here. So a plus b has to be 1. And do a system of equations, right? The next thing that has to match up is that positive 3 has to be equal to the coefficient in front of x over here, which is 2a plus c. So I'm going to write 2a plus c equals 3. And then finally, what? 2, this constant, has to be equal to my constant term here, which is just 2a, right? So 2a equals 2. Now, we don't need our calculators for this. This one works out pretty nice because we know what a is, right? A is 1. If I know what a is, then I can come up here and get b, right? And if I know, well, I know what a is, so if I know a here, I can get c. So I should be able to do this all by hand without the calculator, right? But just for practice, if you have your Texas Instrument calculator, this is an opportunity for us to see how we would use it to solve something like this. Now, again, I wouldn't use the calculator for this, but if this was like a plus b plus c equals 1, and this was 2a, let's say, plus 3b minus c equals 3, then we would want to do something a little faster. All right, so what we're going to do, according to this, does everyone have a copy of this? I put it on the desk in front of you?
Yes, sir.
Okay, so what we're going to do first is we're going to take our system of equations, and we are going to turn it into what's called an augmented matrix. So all that means is you get all your A's lined up, B's lined up, C's lined up, and then equals numbers. Now here I used X, Y, Z, but A, B, C, same thing. They're unknowns, right? So we're going to turn this into the augmented matrix first. So for us, the augmented matrix would be the coefficient on A, which is 1, the coefficient on B, which is 1, the coefficient on C, well, there is no C, so 0, and then the number, 1. Okay, so that's the first row. And now we do the second row. So we're going to have the coefficient on A, which is 2, coefficient on B, 0, coefficient on C, 1, and then the 3. And then finally, 2, 0, 0, 2. Okay, so that's our augmented matrix. Now what we're going to do is we're going to locate the RREF function on our calculator. And that's going to be a little different for each calculator depending on the version you have. So some of you go to the math menu and then the matrix menu. Some of you have a matrix menu separate from the math menu. So if you have your calculator at this time, try and find this function and raise your hand if you cannot find it. If you have that calculator, you're not going to be able to do it with. No. Well, wait, you asked me last class, right? No? That one, I think you can do a matrix on that, but I don't think it has the RREF function on it. Yeah. So this is purely for the TIs. Anyone need help finding theirs? Yes? Oh, is that the Nspire? Yeah? Yeah, I think that's the Nspire, right? You have to bring up your catalog of functions.
There's a math and then
Go to math. No, see if there's a matrix. Oh, matrix menu is the blue one. Under the math key, the x to the -1, you have to hit the blue. Then go to the right and then down. And you'll find it there. So be careful, there's an REF and there's an RREF. Make sure you bring up RREF. It stands for, if anyone's going to take linear algebra, this is called reduced row echelon form. And it just means you're going to find the diagonals, try and turn this matrix into diagonal of ones here. Okay, anyone need help? Having trouble there? Yeah, you should be able, I think you have a matrix menu. Let me see. Is that an 86, 84, 83? Okay, now go use your arrow to go to the right, and that'll be, see how that moved over to the math menu? Now down, and it should be there.
Are you going to return that inverse?
Yeah, I don't think you can use inverses for this, but that's a different sort of procedure. So everyone who has it got it? Yes? Okay, so now what we're going to do is we're going to tell the calculator, we're going to input the matrix. And the way we're going to be using brackets, okay? Brackets and commas. So first thing we do is we put a bracket, not a parenthesis, a bracket, and that should be, what is it, above the 7? I don't know, forget whether it is. You are not required to have a graphing calculator. This is purely just for you, future reference down the road. If you ever need to solve a matrix or a system of equations. My bracket's not above. It's okay, got it? So what is that first bracket telling your computer, according to my little sheet here? What's that first bracket represent?
Is that the first row?
No, the first bracket is the starting the matrix.
Oh, yes.
Okay, so you're about to you're telling the computer, here it comes. Here's the matrix, all right? Then you have another bracket, and that bracket's telling the computer, all right, here's the first row of numbers in the augmented matrix. So now you just put in here, for us it'll be what, 1, comma, 1, comma, 0, comma, 1. And then you close your bracket, and that closes the first row. You have to put the commas between the numbers. Now there's no comma now before the next bracket. So the next bracket means I'm going to start the second row, 2, comma, 0, comma, 1, comma, 3. Close it, that's your second row. And then you're going to do your third row, right? So open bracket, 2, comma, 0, comma, 0, comma, 2. Close bracket, that ends your third row. Now you end the matrix, and then you end the function with the parenthesis. And then when you hit enter, you should see something that looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you should have numbers down this side. So what are the three numbers down this column here?
101.
1, 0, 1. Okay, did everyone get that has their calculator? So do you remember where these coefficients came from? They came from this, right? So if I gave you this and asked you to rewrite this back in this form, this is the coefficient on A, isn't it? So this line would be saying what? A is
1.
A is equal to 1, right? And this one would be saying what? There's no A's. B is equal to 0. And then this last one would be no A's, no B's, but C is equal to 1. Do y'all see? So this is called reduced row echelon form, when you get ones down the diagonal and zeros everywhere else. When you do that, then what you create is a column which represents your answers, right? These are always going to be your answers for A, B, and C, respectively. Now, if this were 6 equations and 6 unknowns, you could type this in, right? It would take a while. You'd have a lot of brackets in there. But in theory, you should get an answer that gives you your 6 solutions, all right? Now, I do realize that there are faster ways to do this on the calculator. If you have some experience, you know, like some of these calculators will let you just put in a 3x3 matrix. The reason why I show it this way is because this works on all the TIs. No matter what version you have, they all have the RREF built into them. So if you can get the syntax correct, then in theory you can do an n by n matrix at any point in time you ever want to, all right? You're not limited by any built-in restrictions, if that makes sense, right? Because some of them, they'll let you put in a 3x3, but they won't let you put in a 20x20. So, okay. So we have our answers, right? Back to the problem now. So this integral should now turn into new integral, and It was a over x, right? And a for us is 1. And then plus, it was bx plus c, right?
So 0x.
But 0x, right? Because we have 0 for b. So it's 0x, so that's not there. And then we have just 1 over, what, this? Like that, right? Dx. So now what we can do is we can do these separately. And the antiderivative of the first one's pretty straightforward, right? Just ln x. And then plus, now I need to do some work on this one, right? How do we handle a situation where we have a constant over an irreducible quadratic? Complete the square. Yep, we're going to complete the square. So let's do that. I'll do that on the side over here. So I'm going to take x squared plus 2x plus 2. Make sure the coefficient here is 1, which it is. I take half of that, which is 1. I add it and subtract it. So I'm going to have x squared plus 2x. Here comes the hidden 0 plus 1 minus 1. We still have the plus 2 here. These three guaranteed a factor, right? To be x plus 1 squared. And then whatever else is left here, which lucky for us, it's plus 1. Boy, this textbook is very, very nice. It's making all these numbers very, very nice, right?
Can we get
Do we like that? Do you like that? Do you like that? Yeah. Okay.
Please, that'd be awesome.
Okay. So now we have this right here now turns into 1 over x plus 1 squared plus 1, and this is where we squint our eyes and we realize that that's really just like
Formula 7?
like what?
Formula 7?
Like formula 17. This is like 1 over u squared plus a squared or something like that. And so we know it's arctan, right? A here for us is 1, and the u is actually linear. We need it to be linear. It is linear. So this, I think we can just go right to the formula, right? 1 over a,
Is 1.
but a is 1, so just arctan of u over a, right? U is the linear expression, but a is 1, so it's just this plus c. That's a lot like that take-home, right? I mean, in terms of, didn't we have an arctan in the take-home?
Yes.
Yeah. I would argue that problem was easier than the take-home one. Okay, so, there we go. Yes?
So if there'd be a 2 in front of the linear, then we'd scale it by 1/2.
If there had been a 2, okay, so if there had been a 2 right here, we would have to scale by 1/2. That is correct. The thing is, we should never get that if we are completing the square properly, because we're always going to pull that, always going to make that a 1, right? So it won't ever happen to us when we complete the square that we have to scale. But just arbitrarily, if I just threw this on the board, like here you go, everyone integrate that, right? You're going to have to scale by 4, 1/4 out front, yeah. Okay, so do y'all want to see the problem that I came up with before class?
Yes, please.
I don't know if we want to do it. I don't think I would test you on a problem like this. Well, I know I wouldn't test you on a problem like this. So is it worth the time? It's pretty long. But there's a couple of things I want you to see from this, all right? There's a couple of things that I thought about giving it as a take-home bonus question. But you know what the problem is? Wolfram Alpha and all those other things out there where you can just go type it in, get a solution, and step by step. It's not even a challenge anymore.
Don't you have to pay for this stuff?
You have to pay, that's true. That's true. So there is some sacrifice involved. So I made this problem up, so it's definitely not going to look like a book problem.
I feel like that.
I just want you to see what we're capable of doing. All right, this is not, it looks horrible, but it's doable. There it is. Okay. So that looks terrible, doesn't it? That looks terrible? Yeah, it could be worse. It could be. Those could be like 50th degree polynomials, but. All right, so let's go through this. Obviously, there's not going to be any like quick U sub or anything like that. Like this is partial fractions all day long. Yes? Degree? the same, which means long division first. Okay, well, long division first. Oh man, okay, x to the 5th plus 5x to the 4th minus 11x minus 62x squared minus 213x minus 194. That's on the inside. On the outside is x to the 5th plus 4x to the 4th minus 7x cubed minus 14x squared minus 44x minus 1. Okay, so now we have to figure out what do we multiply x to the 5th by to get x to the 5th? 1, right? Okay, so we'll multiply by 1. See, I'm like the book. I made it real nice. Real nice number there. 1 times this, right, goes underneath this? Okay, so here we go. X to the 5th plus 4x to the 4th minus 7x. Oh, wait, I left a cubed off here. Sorry, that's a cube there. 7x cubed here. Minus 14x squared here. Minus 44x here. And minus 1 there. Yeah? Okay, come through, change the signs, right? Wow, that's pretty straight. Okay, this becomes minus, that becomes minus, that becomes a plus, that becomes a plus, that becomes a plus, that becomes a plus. Before we get too far, let me just make sure I copied it down right, because one little typo in this and we are going to be stuck. Okay, looks right. Okay, add down. What do we got? Nothing. Just x to the 4th. Minus 4x cubed. Okay. Negative 48 x squared. Negative 169x.
Minus 193.
Minus 193. Okay, how's that? Pretty, right? That is pretty. All right, so here's where we are. You ready? What's that? Yeah, we're good? So can we make x to the 5th turn into x to the 4th? No, this is where we stop. So this is our remainder. Over our divisor, right? Over our divisor. So what we have is, I'll put it here, shall I? Plus the remainder. All over the divisor. There it is. So the original integral, right? This original integral turns into that, doesn't it? That thing right there? And we can integrate 1 easily, right? Not so fun. Not so fun. Fun? Not fun. Fun? Not fun. Okay, here we go. May I continue? All right, so what we need to do now is work on this thing. I'm going to erase this. We're trying to do the integral of this, right? So I know I can do this. This, it's now the power on top is smaller than the bottom, so what's the next step? And well, the first step, partial fractions, is the long division, which we've done. So the next thing would be, what do we do in the last problem? Before that, you have to try and factor, right? You have to try and factor the denominator. Right? Now, in the previous problem, we had, what, x, and it was x squared plus 2x plus 2, or something like that? And that was on the bottom. We said, we said that this doesn't factor, right? But this was a distinct linear, and this was an irreducible quadratic, and we have a method for that, right? A over that, bx plus c over this, right? But we don't have a method for a fifth degree polynomial, right? So we need to factor that. If we have any hope, right? We have to factor that. So that's why I wanted to show you this problem, is I wanted to see how you would even go about trying to factor that. Okay, so I think I'm going to save this. I'm just going to leave it there. I want us to focus all of our attention right now on what I'm trying to do right now is like dig deep into the cracks of your memory to see if you remember how to do anything like this from college algebra. How do you factor something as nasty as that? What's that? Synthetic division. You use well, it doesn't always work, but it's called the rational zero test. So I'll start going through it and see if it rings a bell. You know what, this just doesn't look right. Hold on a second. Something just doesn't look right on this. Give me a second. Is that last number a 1? Yes? Shit. Hold on. The original problem, when I put it up there, was it -1? Oh. I messed up. I wrote it down wrong, but I have it right here. Damn it, why did I do that? Okay, and I got to see if I can fix this. I don't think I can. Go back. Okay, I need you to go back. I think we can fix it, but you're going to have to fix it in your notes since it's gone. On the synthetic, this right here, this last number here is not -1. It's -120. Okay, now I know that seems like a huge deal, okay? So where would that, so everyone's got to change that to 120. Go back to when we did the long division. The long division, first step, right?
Just affected the last.
It's just going to affect that last one. So remember we had the long division, it went like this, and we did 1 here, and then we did all that stuff, and at the very end, what was that last one over here? It was
194 minus 120.
It was 194, right? Negative 194, and we had down here, it was +1, right?
Yeah, so
It's actually going to be what? It's going to be +120. So what's that?
Negative 7.4.
-74. Now is that right? I'm having a terrible day right now. I worked this before class. What the hell's going on? Shit. Just give me a moment, because obviously I can't mess this up more than I already have. Okay, the original problem, x. Okay, the original problem, just verify with me. What the hell? I'm sorry, everyone. This is not the way things were supposed to go. Okay. What is going on here? I'm about to throw this in the garbage right now. Okay, let me get that. You all right, James?
Yeah.
Everything's just falling apart.
Just a little bit of comedic relief to break up the tension.
Thank you. The original problem, is it x to the fifth plus 5x to the fourth minus 11x cubed minus 62x squared minus 213x minus 194?
Yes.
Over x to the fifth plus 4x to the fourth minus 7x cubed minus 14x squared minus 44x, and then we change it to minus 120.
Yes.
Okay. Then we should be okay. Yeah. Okay, so this right here would become
74. Negative 74.
negative 74. Okay? So that changes what up here?
193.
This right here,
Yep.
right? Becomes negative 74?
Yep.
Okay, this still doesn't look right, but we're going to go with it. Negative 74.
And that's still the bottom.
And then this is the bottom, but it's now minus 120. Okay, so we were here and we were saying, how do we factor this, right?
Yes.
That's what we're saying. Okay. So synthetic division. So what we're going to do, I'm just going to erase that. Y'all can tell me what that is later. Okay, so what we're going to do now is we're going to create a list of numbers to try with synthetic division. And the list we create is all the factors of the leading coefficient divided by, or is it the other way around? All the factors of this. Does that ring a bell or no?
P over Q.
P over Q? Yeah? So which is P and which is Q?
P is negative 120, and then Q is what?
Okay, so we're going to take all the different numbers that multiply to be negative 120 and divide them by all the different numbers that multiply to be 1. This is called the rational zero test. So you can start listing out all the different factors of 120 first. So what are all the different numbers that divide into 120 evenly? So 1 goes in there, right? And negative 1. 2 goes in there. Does 3 go in there? Yes. Oh. Does 4 go in there? Yes. And 5 goes in there? Shit. Right? We got all these factors, and it keeps going. I'm going to stop right there. Then I take all the factors of the number in the front, 1. What are the only factors of 1? 1 and negative 1, right? So now what you do is you create this master list. Raise your hand if this reminds you of something you did in college algebra. Okay? Raise your hands if you have no frickin' idea what I'm doing because you've never seen this before. It's okay if you haven't. So this is ringing a bell for everyone, like you've seen this somewhere? I don't expect it to be right here at the top of your memory, but it's why I'm doing this problem. I wanted you to see it again. Okay, so here's my list. I'm going to do this over this, this over this, this over this, this over, but it's 1 here, right? So it's just this list again. Okay, and there's more, but I'm not going to go through them. Now what we're going to do is this creates a list of potential candidates for us to use in our synthetic division. All right, so you ready to start doing it fast? This is how synthetic division works. We put all the coefficients here, 1, 4, negative 7, negative 14, negative 44, and negative 120. All right, so we're just putting all these, just the coefficients. And then we start with our first number on the outside, 1. Does that look familiar, synthetic division? You drop the 1, multiply. 1 times 1 gives you 1, put it here, 4 and 1, give you 5, you're adding down, multiply, 5, add down, negative 2, multiply, add down, multiply, add down, what's that, 60? It's negative 60?
It's negative 60.
And then here to here?
Negative times negative 60.
So this is negative 60. And what do we need to happen for this to work?
The remainder is to be
We need this to be a 0, which it's not here, right? So did 1 work? No. So what do we go and do next? We try negative 1, and then you go to 2, and then negative 2, and you're hoping to get 0 here eventually. I believe, I'm going to save us some time, negative 2 is going to work, okay? Negative 2 is going to work. So I'm not going to do negative 1. I'm not going to do 2, because those would both fail. I'm going to get to negative 2. So I've got to redo this. You see what I mean? Like, I wouldn't expect this on a test. I really wanted to show you just like what you could possibly do with this, you know? It could get this bad. 1 here, let's see, negative 2, add down, that's 2. Negative 4, add down, negative 11, what, 22, 8, negative 16, negative 60, and negative 2 times negative 60 is 120, and there you go, you've got your 0 there, okay? So what does that mean, okay? What does that mean? It means that negative 2 is a 0 of the polynomial, which means that x plus 2 is a factor. This is the way I like to write in my college algebra class. If I ever get this on synthetic division, and I get a 0 here, what I say is this. This factor, that 0 tells me that x plus 2 is a factor. See the opposite of this. X plus 2 must be a factor, because this is telling me when I plug negative 2 in, I get 0. So that means that has to be a factor. And then the remaining numbers here are the remainder of the polynomial. Right. But it's going to be 1 degree less than what we started with. And we started with the 5th power, right? So it's going to be x to the 4th plus 2x cubed minus 11x squared plus 8x minus 60. All right, so we have factored, haven't we? We've factored. We know that it's x plus 2 times this. That's a distinct linear factor, isn't it? Yes, sir. So I can do a over that. But what about this piece? I got to try and do factoring again. Some sort of synthetic division again. Now the good news is you can just continue your list. Right? You can just continue using that same list. So what I'm going to do now is set up a new synthetic division. And I'm going to do this one. So I go here, got 1, 2, negative 11, 8, negative 60. For those students who really do recall this, what number would I start with right now? So if I've done 1, negative 1, 2, and negative 2 is the first time it worked, then what number would I start with now? Start with negative 2 again. Because you could have a double factor. You could have x plus 2 be a multiple factor. So you start with negative 2 again. Now it's not going to work, okay? The next one that works, I believe, is negative 3. So you would try negative 2, it wouldn't work. You would try 3, it wouldn't work. Negative 3 should work. Let's see, I don't know. Is it positive 3 out here or negative 3? Positive. Oh, it is positive 3 that works? Oh, it was negative 2 that worked, and now positive 3. So 1 here, let's see, 3, 5, 15, 4, 12, 20, No, what the hell? What'd I do?
60.
Yeah, that is 60. I'm really having a rough day. I'm having a rough day. Tell you what happened, no excuses, all right? Life happens to all of us. But my daughter's favorite fish died. It's been a rough day. It's been a rough day.
Is that like Nemo 10 or something?
Pardon?
Is that like Nemo 10 or something?
Well, she's had that fish for like 7 years, and it was her favorite fish. You know, like if anyone's dealt with a fish tank, there's a disease they get called ick. Has anyone heard of that? Usually ick will like wipe a whole tank out. And in order to like save them, you have to do like
You have to
swap out the water multiple times a day, like for weeks.
Add antibiotics.
Yeah, there's all sorts. So I did that, right, a couple of months ago. I mean, I saved that damn tank. I worked so damn hard. She's like, I don't care if all the other fish die. Just don't let Lenny die. That was her fish's name, Lenny. And I saved his ass, but he's no longer with us. So I'm okay. Okay, I'm just thinking about my daughter today a lot, you know, because it's like, do you send her to school? It's a fish, you know. If it's a dog, you know, you stay home, you mourn. Okay, sorry. Back to this. So here we go. Same story, right? What does this tell us we have a factor of? x minus 3. And then this should be the remaining polynomial, what power? X third, right? Because it started at the fourth. Remember, we are focusing, like our synthetic division is breaking that piece down. We already have this, right? Okay, so this is going to be x to the third plus 5x squared plus 4x plus 20. Shit, are we going to have to do it again? No, because I made the problem special for you. This is 4 terms, right? And this will factor by grouping. Okay? So let's go ahead and do it right here. It's grouping. So we have x minus 3 out here. Don't confuse that with this. And then this, if you slash it here, what can you pull out? X squared. I think I'll get rid of this. So I want to be able to write my final answer here. So I'm going to do my little grouping up here. I pull out an x squared. What am I left with? X plus 5 there. And then when I pull out a 4 from here, and I'm left with the x plus 5. And now they match, right? So my next line under here is going to be, and you can write it either way. I like to write x plus 5 and then x squared plus 4. We're there. We're there. All right. Yeah, this was just to factor the denominator. Yes?
Would that be b c dx plus e?
We're not there yet. Let me go back and say where we are. Okay. So we had first started the problem. We did long division, right? We did long division, and we had integral 1 plus, and then this is, I erased it, so you're going to have to help me. What was the top?
1 plus x to the 4th
Okay, x to the 4th,
minus 4x to the 3rd
4x to the 3rd,
plus 8x squared
plus 8x squared,
minus 169x
169x,
minus 193.
193.
Oh yeah,
Wait.
minus 120. Oh, minus 74. Sorry.
Minus 74? Okay. Do we have enough people agreeing? Okay, and the denominator, right? The denominator of this was the x to the 5th, all that stuff that we just spent a lot of time factoring, right? And this is what we got it to be. This thing times this thing times this thing times this thing. Do you all see that? So it's going to be x plus 2 times x minus 3 times x plus 5 times x squared plus 4 dx. Okay, are you all clear on where we are now? Yes, sir. Long division gave us that first line, but then we went and looked at this denominator and went through synthetic division twice and then got a grouping factoring, and we got the denominator factored, right? We got it factored. So now we have to take a look at those, and we have to decide what we're going to do with each of them. So distinct linear factor, distinct linear factor, distinct linear factor. Quadratic, irreducible. Okay? Quadratic, irreducible. So here's where I would stop the integral and do my partial fraction decomposition. I've got to get x to the 4th minus 4x cubed plus 8x squared minus 169x minus 74 over the junk. I'm just going to say junk. That's all the denominator, right? That's all that. Must equal a over x plus 2 plus b over x minus 3 plus c over x plus 5 plus, drum roll, dx plus e over x squared plus 4. What is what, 48?
The 8x squared is supposed to be 48x squared.
Oh, this is 48 right here?
No, to the right. 8x squared.
That,
Yeah, it's supposed to be 48x squared.
48x squared. I didn't hear the 4. Okay. That's important. 48x squared. This is the type of problem where it would be a lot better if I could have just started on that end of the room and went around like that, but I'm trying to get it all on video. Yes?
Yeah, it's negative 48.
What? Okay. I asked if y'all, okay. Negative? Why aren't you? Tell me now, because we got to go get A, B, C, D, and E. So if those numbers are off, like, we're in trouble.
Right.
Yes? Negative 48x squared. I'm going to hope that you'll have this right. Okay, what next? Clear the denominators, right? So multiply both sides by the junk. And so the left side is going to be x to the fourth minus 4x cubed minus 48x squared, I'm being told, minus 169x minus 74 must equal, okay, a. And then what's going to be next to the a? Oh my goodness. Everything else. Right? That? Isn't that what it is? Plus, and then b times x plus 2, x plus 5, x squared plus 4, not done yet, plus c times x plus 2, x minus 3, and then x squared plus 4, and we still have another one, right? Plus dx plus e times x plus 2, x minus 3, x plus 5.
You weren't kidding when you said it was a monster.
Yeah, I told you it was going to be a monster. And I'm delivering. All right. We could probably get some of these variables with a shortcut method, couldn't we? Yes. In fact, we could probably get 3 of them. 3 of the 5, right? Now, I will say that if you're willing to go through the arithmetic of expanding all this out and matching up coefficients, right? This would be a perfect problem for the calculator, right? It'd be a perfect problem for the RREF because you have a system of 5 equations and 5 unknowns. But let's try and do it shorter. Okay? I'm not going to go past 2 on this problem. So wherever we're at 2 o'clock is where we're stopping. Okay. So the next step, what I'm going to do is shortcut. So let's try and figure out what A is. If we wanted to know what A is, then how could we get A by itself? Could we? Let x be what? Negative 2. Negative 2 will kill this, this, and this. So to find A, we're going to let x be negative 2. Oh my goodness. We got to plug negative 2 in over here? Right? Don't we have to plug negative 2 in over here? Hey, does anyone know? Never mind. Never mind. Does anyone know a short way to plug negative 2 in there?
We will in a minute.
Someone plug negative 2 in while I'm doing this. Negative 2. Do it on your calculator or do it in your head, whatever. What is that? Negative 36. 60, 72. What is that? Shit. 90. What is that? 97? I think. Yeah, 97. Negative 97. Yeah, 194. And then negative 120? Oh, no, 120. So did anyone get 120? Yeah, that's what you get when you plug in negative 2. No, not 120 here. Did anyone actually plug negative 2 in over here? Yes. And did you get 120? Yes. That's the same. You can do it that way also. Like what you get when you put that number in here into synthetic division, what your remainder is actually the value of the polynomial at that number. Which is why when we say the remainder, what do we want it to be when the synthetic works? 0, and that's because that means when we plug that number in, we get 0, which means that must be a factor. But you can also use it just to evaluate the polynomial. All right, so we get 120 on the left side, right? So the left side's 120, and what's the right side? Well, we have to do A, and then negative 2 here, and then negative 2 here, and then negative 2 here, which would be 8. So what's that? Yeah, it's negative 120, so A is negative 1. Oh, we have A. Good. 4 to go, right? And then we get B. You get B by doing what? I'm just going to write it down. How would we get B? Can we get B? B, let x be 3. It would kill off this, and it would kill off this, and it would kill off this. So if x is 3, you get that, okay? Now, I think I'm going to save us time. If you do that, you should get 2, okay? You should get B is 2. You have to let x be 3, and you'll get B is 2. And then can we get C?
No.
Can't get C? Yeah, 5 is not negative 5 here, negative 5 there, negative 5. Yeah, we can get C. So if you let x be negative 5, you'll get C is equal to 1. Now, the hard part is going to be getting D and E. So you'd have a couple of options. You could replace A with 1, or negative 1, B with 2, and C with 1, and then let x be some random number, and you would have one equation, and then you let x be a different number, you have a separate equation, you have 2 equations. I'm not going to go through it, all right? The whole point of this is we could do this at this point, right? I mean, like, we could go through the arithmetic of this if we needed to. More importantly, though, once you're here, right, if this is a number, 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 then can you handle the integral? Yeah, this is just going to be natural log, right? Natural log, natural log. Not quite formula 17.
You're gonna have to go through.
Well, you'll end up breaking
You could break it into 2 different integrals, right? And then, like, one of them will be a constant over this, that's formula 17. And then d times x over this, that's just a basic u sub. That's just a basic. So it would be doable. Okay, let's pull the plug on this, yes? Yes. So why did I do this to you? Yeah, I wanted you to see synthetic division to factor a polynomial, all right? Not that I would ever ask you to do it on a test or anything. It's more for you moving forward as engineers or you should know that you shouldn't be at a point where you see a polynomial that's higher than 3rd degree and be like, I don't know what to do. Like, you do have a technique. It doesn't always work, but you should know that that's still like in your toolbox. Like, it's there, all right? What else did I want you to see? Long division of some nasty stuff. I wanted you to see this, but we just don't have enough time. I really did want to expand this. Like, I wanted to multiply this all out, and then I wanted to go and put it into our calculator. But we're just out of time. Yes?
You want me to bring up about the TI-89?
What about the TI-89?
So, like, a few of us, including myself, can have them in other classes. Your official policy for this class.
Mm-hmm. My policy on the TI, well, it's not just the TI-89, it's any calculator that can do this, like, you can type this integral in and get the answer, which you can do on the 89. Like, it'll do antiderivatives and give you a general solution with the, like, plus C. So it'll do everything we're trying to do, and it'll do it in a couple of keystrokes. So that's why I don't allow them. Now, I used to allow them, but then what I saw was just, I would start a test and students were like, that's all they were doing. They weren't writing anything down. They were just, you know, and I'm just sitting there like, it's not in there, right? It's in here, it's not in there. So that's why I kind of ban them. Yeah.
What about Cal 3?
Cal 3? We don't need it as much, you know? I mean, this class, a lot of it is about integration, so I want you to be able to do it and not depend on your calculator for it. So I don't think I have as much of a problem in Cal 3, but I'm not going to say anything officially.
Okay.
Yeah. I just don't want it to become a crutch for everyone. That's all. Okay? And trust me, it does become a crutch if you use it like that. So, all right, I'm done with partial fractions. In fact, we're done with the techniques of integration. All right, so we've covered everything that we're going to cover. There is a section in the book